Well, hello there. Let's check out this example together. In this example, we have a combination of capacitors that are on parallel and on series, and we need to find the equivalent capacitance of this circuit across these two terminals. So all of this here, we need to find the equivalent capacitance for all of this. Assuming that C, the capacitance, is equal to 1 microfarad, we have a collection. There's, for example, this is 1C, this is half a C, which is 0.5 microfarad. This is 1/3 microfarad, this is 2 microfarads, and so on. You get the idea. So we need to find out where and what the capacitance of this whole circuit is. Okay, there are actually at least 4 points or 4 regions where you can start collapsing capacitors together. I will give you like a clock of 10 seconds to think about that. Pause the video a little bit and try to do this problem on your own and see where you get stuck, or at least see where you can start. Okay? All right, thank you. All right, I hope you paused the video and probably you found different areas where you can start. So these are all on parallel. You can start here. These two are on series. You can also start here if you want to. All right. Now these three here are on series. You can put them together if you want to. These two here are on series. You can also make them together. However, you cannot, for example, do this one and this one together, these two, because this one is connected to this one and this one is also connected to this one. So it's going to make it hard and it's going to make it incorrect to do it this way. Okay, I prefer if I can start here. That's my choice. And I would say these are all on parallel. So when capacitors are on parallel, so for this one, the capacitance that is equivalent for this one will be equal to 2 plus 2 plus 2. So this is 6 microfarad. Okay, now I'm going to delete all of that, and then I'm going to just make it 6 microfarad. Okay, so what else can we do? Now we can do these three together on series, and the equivalent for these on series together, I'm going to make it here. 1/C equivalent is equal to 1/6 plus 1/1/2 plus 1/1/2, and 1/C equivalent, after calculating it with the calculator, is equal to 4.17 microfarad, or 1/microfarad, but we don't want 1/C equivalent, we want C equivalent for that combination of 3 capacitors on series, and that will be equal to 0.24 C. Now notice that 0.24 C for all of this combination is smaller than the smallest one, which is 0.5 C or 0.5 C here. Okay, so right now we can actually just delete all of this here. Now we can, okay, so this one looks like this, and the answer is this is 0.24 C. Alright, so let's go back here. So we have now these also on series. Let's find the equivalent capacitor for all of these on series. So I'm going to say 1/C equivalent is equal to 1/1/3 plus 1/1/, because this is 1/3 too, plus 1/1/3. Okay, and 1/1/3, this is equal to 3 plus 3 plus 3, and this is 9. So that's for 1/C equivalent. So C equivalent will be equal to 1/9. Okay, so I'm going to delete all of that here. I end up with only 1/9 C. Okay, now let's do this one and this one together. These are also on series. So for this whole thing here, 1/C equivalent is equal 1/1 1/2 plus 1/1/2. So 2 plus 2 is 4. So that's 1 over C equivalent. Then C equivalent is equal to 1/4 or 0.25 C. So this whole thing I'm going to delete to make it just 1. And this one here, 5C. Okay, so good. Now these are parallel. We can just add them together. So whatever 1/9 is, so 1/9 is equal to 0.11. So this is 0.11 C. 0.11 C plus 0.25 is 0.36. So I can delete all of this combination and put 0.36 instead. So I'm going to delete. Okay. And that's equal to 0.36 C. Alright, now all of these are on series or in series together. Okay, so what we can do is just actually add them in series, which is, I'm going to do it here for all of them. 1/C equivalent is equal to 1/0.24 for the first one here, plus 1/0.36 plus 1/1, and that will be equal to 7.9, but C equivalent will be equal 1/0.79, and the total equivalent capacitor or capacitance for all of this is going to be equal to 0.125 C. So this is the answer for this problem. Okay, I hope this helped. Thank you very much for watching. Have a good day.